This whole thing is a very stupid debate. Anytime someone says it's around the corner, AGI is around the corner, I'm like, tell me how. How do you know? It makes me angry. Here's the thing. Assessment of LLMs in the context of your application is exactly the same pretty much as assessing if an application works. You still need your unit tests. You still need to inspect things like traces. You still need to get humans in the loop to check things out. You still need to do A/B testing.
So, welcome to the very first inaugural episode of The Marco Show. I have a very wonderful guest with me today. Who are you and what do you do?
So I'm your colleague. So I'm also a developer advocate.
You kind of
at
look familiar.
I would hope so after 3 years.
Yeah.
So yes, I'm also a developer advocate in JetBrains. My specialization is data science. Been a data scientist for about 10 years now.
Right. So you started out in data science right after uni. That's what you did?
Right out of uni, but in the sense that I stayed at uni for a very long time. So I did a PhD in psychology and I also stayed on for a postdoc in biostatistics.
Right.
And then I fled academia and went into the warm embrace of data science.
Right. Okay. How are you involved with LLMs?
So I basically do a lot of work kind of building projects in LLMs, doing education about LLMs. I've done a lot of talks about LLMs in the last 3 years.
Mm-hmm.
My particular stance is because I worked in natural language processing for quite a number of years in my data science career. So basically I like to say I was working on LLMs before they were cool.
Mm-hmm.
I was working in NLP in the pre-LLM era. So pre-2018.
Right.
And, there are a lot of methods in natural language processing that are not LLMs. We can also talk about them. We started experimenting with the very first LLMs, the ones coming out of Google like BERT, right at the end of that job. So yeah, basically I've sort of seen their applications, seen sort of how they can be used. And I've also seen a lot of claims about how they can be applied, which I'm not entirely convinced about.
I love it, and I mean, we talked before the show, and I was saying you're kind of the antidote to the hypers out there, just giving you a bit of a more neutral context where LLMs are, what they can do, and how to choose them. And that's the topic I'd love to kind of get into.
I think you have a lot of questions for me.
I do. So my issue is, and I'm not making this up. So I go to any of our IDs, for example. I look at the AI chat window. I have a selection of 20 different models to choose from. And it's not just about, we have Google with the Gemini models, we have then OpenAI with the GPT models. And by the way, sorry, Anthropic.
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 Anthropic. I know it's the TH sound. Yeah.
Yes, Anthropic.
Yeah.
With Claude. And then I have, these submodels, the families. And I was thinking, to me, it feels like in Europe, or at least in Germany as kids, we had these card games, which are called car quartet, where essentially you play cards and everyone has different car models, and you have, they have benchmarks written on them with the top speed, engine, horsepower, whatever, and then you just compare these numbers and then take the cards from the other players.
Mm-hmm.
And to me, when looking at all these models, I just see, context sizes, I just see throughput, random numbers, new versions of models. How do I go about choosing, or even maybe just understanding what these models can do and which one should I choose, essentially?
Yeah. So part of kind of I think the confusion about LLMs is they've sort of been marketed as a one size fits all for all problems. And even though these models are better at generalizing with natural language tasks than anything we've seen before, they still have particular training sets. They still have particular things that they tend to excel at and things that they tend to be weaker at. So kind of maybe I can give like a brief, well, it won't be that brief, but a slightly brief history about how we got here.
Sure, yeah.
So basically, we struggled for a long time about how to actually process natural language. So to define natural language, it's what we're speaking right now. It's any language that is not designed. And it's really complex to process because things like word order or context, things like this, they matter a lot. And actually keeping track of all of that, keeping track of that even within a sentence, but over multiple sentences is really tricky. So before LLMs, we had a type of deep learning network called long short-term memory networks. Really catchy name. So things are named very strangely in machine
Long
learning.
short-term memory networks.
Yes.
Okay.
Yes. And the idea of these is that they could keep track of words in sentences. So basically, the network would go sequentially over, say, a sentence. It would learn something about the first word. It would store that in the short memory, in a long-term memory. And then basically the short-term memory would then go to the next word. It would add extra information to the long memory and it would accumulate information. But there were many limitations with these models. First, like training things sequentially and running things sequentially slow. But also, these long-term memories couldn't actually hold that much information. So they start failing actually after about 20 words.
Right.
Yeah. So, but they were the best we had. And then in 2018, a paper dropped called Attention is All You Need, and it put forth the transformer network. And transformer networks, at their core, they have a mechanism called self-attention, which is far more efficient at helping the model to understand which words are important for gauging meaning within a sentence. So the very first transformer model was called BERT. It was by Google, and it actually wasn't a GPT model. What it was actually trained to do was work out two natural language tasks. It's what's called an encoder model. It was designed to try and predict what a missing word was in a sentence, and with two sentences, work out which order they're supposed to go in. And by forcing the model to do this, it basically meant that it had to learn a lot about how the language functioned. So you ended up with these layers in the model, which are now called encoder vectors. They're used for a lot of different things. And basically, these vectors help you kind of process text, and then you can change the downstream tasks. So you can change the downstream tasks to, say, classification, sentiment analysis, things like that. But these models don't generate text. And the big problem with building encoder models is you can imagine this data set, you have to design by hand what the output is. So then the idea of, okay, what if we do something like next word prediction as the task? So say we get a sentence, we just split it at a point and we say, here's the input, all of the part of the sentence, and the output is you have to correctly guess the next word. And these were the generative pre-trained transformers, the GPT models. So over time, building these models, they were able to scale much more readily because the size of the data set can grow a lot bigger because you're essentially not having to do anything to it other than some cleaning. And also, they realize that the bigger you make them, the better they are at doing a whole range of natural language tasks. So by the time we hit GPT-3, which was OpenAI's model, you're looking at a model that can do a lot of things we're familiar with LLMs being able to do now. They can encode parametric knowledge. They can learn things from the data. They can do a lot of sort of basic reasoning tasks and stuff like that. So where we got to is an arms race. We're trying to make the models bigger and bigger and bigger, like scaling them. And you'll hear this term like parameters. We're getting into billions of parameters. It's just the size of the neural network. They got very expensive to train. They're very expensive to run. And at the beginning of this year, a Chinese company released a model called DeepSeek that rocked everyone to their core because they were able to achieve pretty good performance comparable with these massive models with a much, much, much smaller network, much, much smaller to run, much, much cheaper to run. So,
which brings me back to maybe car quartet. So from the outside, and I have no clue about most of the stuff, could I just then have, by default said, well, a new version with so many more parameters by default then is just better? Or is essentially what DeepSeek did show that is not the case? Or how does that work out? I mean,
yeah. So in order to improve models, there's sort of a few different things you can do. So one is you can just make it bigger. You feed in more data and you make the model bigger. And this was the most reliable way of achieving better model performance. But neural networks, you can sort of customize them and design them in a lot of clever ways that are better at extracting meaning out of the data. And so basically, it's that DeepSeek used a few tricks, not just with model architecture, but with the way that they trained the model, that sort of managed to extract a lot more meaning with fewer parameters. Because if you think about the way that these models work, you have an input. An input is a bunch of words. And each of those words will kind of be processed along a path as it goes through the network. And at the end, it will come to one conclusion. What's the next word? But most of those paths aren't used in a single prediction. So being able to sort of trim the networks down to what is actually the most useful paths, either through like at the beginning of the training process itself or afterwards, a process called distillation, basically allows you to build more compact models. They're just better at sort of extracting information efficiently.
And what's the state of DeepSeek now today? I mean, do you know if it kind of can compete with all the other, fancy models out there?
It's interesting. So in terms of competing, it's also in the open source realm. So we can kind of talk about proprietary versus open source. But in terms of model performance, yes, it does seem to be holding its own, not with the big, really huge models, but at least they have a reasoning model which holds its own against some of the state-of-the-art reasoning models. And their generalist model also performs quite well. So this is why everyone was so shocked, because it's not like it was, half as good or a quarter as good. It was almost getting into the realm of as good.
With the state-of-the-art reasoning models, though, would I then just by default assume, having no other information as an end user, that still context size and parameters and new version automatically means better?
Okay, so not necessarily, and defining better. Oh my God, I have a whole talk about this. So assessment is one of the most neglected and most difficult areas in natural language processing. So assessing whether you have a good model is really hard, even when it's for a specific task, unless that task is something like discrete, like you're trying to predict something like an emotion.
Right. And we're just assessing the quality of the output, essentially.
Yeah. And this is my chance to say, what we've forgotten with LLM hype is we're still talking about machine learning. So machine learning is not just models. Machine learning isn't decision trees or boosting models or whatever. Machine learning is an approach to working with data that is structured and gives you kind of ideas about how to assess model quality. So the goal is to create a model that works in production as well as it does in a development environment. So machine learning gives us the tools to do that. And people have just gone, oh, we have magic models now that can do everything, so we don't need to think about basic machine learning practices. No, we do. And it's coming back to bite us in the ass because we haven't thought this stuff through. So what kind of happened with the beginning of all NLP assessment, but also LLM assessment, is they were designed to do natural language tasks. So we have a bunch of natural language benchmarks. I'm not going to say they're perfect, but it's like, okay, can this model do classification well? Can it do question answering? Can it do summarization?
By the way, just classification for anyone you just have for example, some sort of a text and you say, hey, do you have an example do you have a classification example?
Yeah, so I recently released it, not recently, it was 6 months ago, but I released a tutorial where we were trying to classify books into fiction or nonfiction.
Right.
This would be a classification task. So based on the description, is the text describing this? Then people started noticing, oh, these models seem to be able to do other things. They can reason, and they can, with the parametric knowledge, they can answer questions on exams. So they seem to know things about history and math and science. And then we started making claims about AGI. I've gone there early, actually.
You've gone there early. I wanted to ask you later on. Yeah,
we can come back because this one's
this is a biggie.
But basically, people have started creating or reusing assessment techniques to see how well LLMs do this stuff. Now, so many problems with these assessments. Firstly, like some of them were just created using things like Amazon's Mechanical Turk by people who like they have no investment in making this good. It may also be English is not their native language. And some of these tools are filled with gibberish. I am not joking. Like questions that do not make grammatical sense and they don't actually have a correct answer if you as a human are trying to assess them.
Right.
So this was sort of the first generation of assessments. The second generation, they've tried to clean things up a bit. We also have problems with things like there's a phenomenon in machine learning called data leakage. It's basically where a model performs very well because it's actually kind of seen the answers. You're actually shown it the things that are in the data set you want to test on when you trained it. So it's kind of memorized the answers, like a student cheating at a test. And there's pretty good evidence that there's a lot of data leakage of assessments into model training data sets. And this continues to be an ongoing problem. So now they're trying to make these assessment sets private. But beyond all these problems, the fundamental thing is that you are trying to sell a model as good, okay, but you, Marco, you come in and you want to use a model for something specific. You will want to do a task. You might want to code. You might want to
transcribe some audio, for example.
Transcribe some audio.
Or generate images, I don't know.
Yeah, exactly. Or LLMs can't do that, by the way, but yeah, just as an aside. But related machine learning models that have come out in the last 5 years have also had advances. But basically, like maybe you want to, I don't know, you want to research something. So you put in a paper as part of the context and you want it to answer questions. You know, knowing that a model is good is not that helpful if it's scoring at all these random benchmarks that assess a whole bunch of things. And you want to know how good it is at completing code. So that was a very long way to say assessment is fucked. And it's just...
So I was actually thinking about that. So as an end user, again, who knows nothing, would I just take a random task, a coding task, send it to, I don't know, 3 different models, then just, you know, do 2 or 3 examples and then take whatever I think gave me the best response and I'm just going to stick with the model and that's it? I mean, what can I do essentially as an end user?
I think basically a lot of it seems to be based on vibes at the moment, right? Like it's like my gut feeling is that it's better at that. There are specific coding benchmarks. So say you want to look up, or so you want to use a model for coding, you can go look up that benchmark and see how well different models have scored on it.
Would it tell me if I go to a benchmark and then it says, well, that model got 42 points, the other one just got 39 points. Does that tell me, hey, great, 3 more points means so much more, I don't know, that much better of a model?
And this is the problem with assessments, right? You need to understand like what population are they assessing? Is your target language even represented? Are the tasks you're doing actually represented? And how are they assessing good? Is it, does the code compile? Is it the number of errors? Is it the maintainability of that code? So this is the problem. I don't think people are looking at stuff in this depth. It's just you want one number to boil it down to because everyone's confused. But unfortunately, I'm not here to necessarily tell you there's a magic bullet. Like there isn't. I would say that like generally the models do seem to do okay in coding tasks for languages for which there's a lot of training data.
Can I even tell somehow what a model was trained on? Or when I now look at these big models, I just assume, as you said, a general purpose model that was just somehow trained on everything. And then someone told me in some, I don't know, Firebase YouTube video, oh, by the way, Claude was more trained specifically on code. And that's why I'm using it for coding. Do you have any idea what these models were trained on?
This is also a major problem. So with the early culture around LLMs was they were all open source. And so the data sets that they were trained on were released and anyone could go and look at them. But one of the competitive advantages, even for open source models now, has become the data, because it's one of the few differentiating factors that's left. And so most of these model creators will not tell you what the model was trained on. So you might say in the paper that they release or in the marketing material, get a general overview. And this may be where people are getting these numbers from. There's also just a lot of rumors that fly around. So people might just be making stuff up. Maybe they asked ChatGPT and it told them and it hallucinated. Who knows? But the best you're going to get is like what the model creator will release to you. And they will not release the data generally anymore. So you yourself can't go check. There is also the fact that these data sets are massive. So searching them efficiently is really hard. But
there's interesting thing is with the marketing material you just mentioned, when I go online and then again, I see massive update, changes everything. And now the model, much higher throughput. I've asked you before, I think, thinking models, non-thinking models, what these are actually also. And then you see all these updates and now you have adaptive thinking and all these words, elaborate thinking, stupid thinking, slow thinking, fast thinking. I'm just reading through all of that and thinking, what the hell is going on? What should I do with all of this?
yeah.
And by the way, could you just briefly explain what thinking versus non-thinking is, if you mind?
Yeah. So we've kind of talked about reasoning
Mm.
in the context of LLMs. So LLMs can't actually reason. They can kind of emulate and pattern match and do something that looks a bit like reasoning. I just want to clarify, they don't actually reason in the way that humans do. But what people discovered is that models are particularly bad if you just straight up ask them a question, like let's say like a math question. This is always the classic. Like Jenny has 4 balls and Sam has 8 balls. How many balls do they have together? Right. And usually it'll just randomly come up with a number. But you can do particular ways of prompting these models. One is called chain of thought, where you can show it how to break down these problems. So if I had this problem, then I would need to say first Jenny has 4 balls. Then I would need to identify that Sam, I can't remember what name I came up with, has 8 balls. I need to add them together and that gives me the final answer of 12. Now I give you another problem. So this problem decomposition seems to work a bit better. A recent paper came out, I think it was from Apple. Apple doing amazing research, by the way, around like the limitations of these models, like really interesting stuff. But this Apple paper seemed to show that like even with these sort of ways of prompting models and thinking models altogether, their ability to do problem decomposition really just, it exhausts at a point. You can't work around this limitation. So yeah, thinking models are either prompted in such a way that they're told to think more. They're given examples through chain of thought prompting. They may be fine-tuned in such a way that they are shown a lot of such problems. But the thing is that thinking models usually are a lot slower because internally they will be looking for multiple possible solutions to a problem. And this gets more complex when you then start building sort of like thinking agents. We can come back to agents as well. But generally, like then people are like, okay, it's good if they think sometimes. We don't need them to think all the time. And so these adaptive thinking models are basically, okay, we've trained the model in such a way or built an application, agent application in such a way that the model doesn't always default to this deep thinking process. It may sometimes think when it needs to, and when it doesn't, it just is cheaper and faster. So
it doesn't make the whole topic any easier, I feel.
the topic's not easy.
But it's being stuffed down your throat as being really easy. It literally is like a couple numbers, choose the latest model. And then, for example, when I use some of the competitors for fun, and then you basically go back for coding itself and you fall back to trial mode, it basically brings you to a cheaper model or to the later to a version want to go, and you're thinking, oh, does it now mean I'm using a totally dumb model? It can't do anything anymore. Do I need to spend the money on premium tokens and otherwise I will just get crap answers? It's all stuff which is very confusing to someone who just wants to code and just wants to get something done.
Actually, that reminded me of, I did talk last year for GoTo, and I did a little demo at the end on like a really simple RAG application. So it's basically you have a PDF, You get it sort of broken down into vectors using these encoder models. And then you can basically search through for the most semantically similar vector to a query. So you basically search through it. And I use GPT 3.5. I really like this model because, to be honest, it's still a very powerful model and it is cheap as chips to use. And I got a comment on the video saying, it's very nice, but she's using a very out of date model. And I'm like, it's fine for what I need it to do. Like, you don't always need to use the most state of the art model.
But that's because people really can't judge what they're kind of using.
Yes. And all forgiveness in software, normally using the latest is best. It's got it's more secure. Like if you're using the latest hardware, it's usually get more bang for less money. But it's not quite the way things work anymore with LLMs, because training these models is so freaking expensive, so slow, and we have plateaued, honestly, in terms of advancements we're seeing. So models that are 2 years old are still competitive, I would say, ish, with models that were released this year.
How do I've had that issue myself, how do I actually handle hallucinations, and not just the hallucinations, but actually the confidence that comes with it? So you get very confident answers. You have to really, really understand the topic to figure out, hey, the LLM is lying to me, kind of.
Mm-hmm.
And then also the topic of, I feel maybe with more and more AI generated content and the training you just mentioned, I mean, it's kind of a self-reinforcing loop that the answers get worse and worse.
Mm-hmm.
What's your take on that? I mean, on that whole topic.
Wow, big topic. So basically, hallucinations come because models are trained on a limited data set, right? So you have two types of hallucinations. You have factuality hallucinations, where the model has actually just learned something completely incorrect. Maybe it got trained on some conspiracy theory blogs, which does happen, by the way. So they've internalized knowledge that is false. And then you have faithfulness hallucinations. And this is where, say, you have some sort of reference, but it can't actually, say, summarize it properly or answer questions from it properly. So it can reference to something, but it can't actually reproduce the information it sees in a way that's correct. And both of them are major problems. The way that we've tried to deal with, say, factuality hallucinations is trying to give the LLM access to more up-to-date and correct information. So one of the first ways to do this was RAG, retrieval augmented generation. That was the hotness last year. And generally, there's nothing fancy about it. Generally, the idea is you just somehow give the LLM access to an external knowledge base and you say, please use this preferentially over your parametric knowledge. But again, problem is sometimes you don't want it to do that. Sometimes the parametric knowledge would be okay. So there's also clever ways to do RAG that is in a way that is also adaptive. The problem is, though, if you have a model that has high faithfulness hallucination rates, even if it has access to the correct information, it won't be able to do it properly. And so, yeah, I don't really know what to tell you about treating hallucinations. It seems to be an unsolved problem in many ways.
Do you find yourself Googling more, or also asking instead, for example, ChatGPT instead for the right answer to any of the stuff you might have Googled like a year ago?
It depends. If it's something, okay, I will confess a way that I use ChatGPT. So ChatGPT, by the way, I should also explain. ChatGPT, Claude, all these are not models anymore. They are actually agents. So they're a whole application that is built around an LLM, which the LLM acts as the reasoning engine. And this reasoning comes up again, reasoning engine. And it can basically access a bunch of tools, say search engines, image generators. It can access documents that you upload, et cetera, et cetera. So basically, I like to take advantage of that. And I won't necessarily ask it stuff that I could Google, but say I need to work with say I want to work with a new research paper and I've read through it, but I just want to ask a few more questions to clarify things, maybe get it to cross-link with other things. I would upload that to ChatGPT and then chat with the PDF. This is what RAG was always advertised as at the beginning. I think this is neat. I wish I had this during my PhD. It is super. Sometimes it still hallucinates, but you can still then go to the source. And I always ask it for sources. And then sometimes it will hallucinate the source, but then I'll go and check.
Which means you're in that way kind of, so you get an answer and you basically in your mind think it's 80% correct, and you always have the feeling of, I need to double check this.
Yes. Yeah. I never, ever, ever use ChatGPT in a way, or any other LLM, in a way where I cannot verify the answer, because you just cannot trust it. And it's exactly the same as you and I remember early search engines. I'm sorry to cast such an aspersion on you, but it's true. It's true.
Yeah.
The early internet was wild, right? Like the early search engines didn't index things based on quality or like even like cross-linking and things like that. And so the quality varied. And I think a lot of millennials have that experience of, okay, like you kind of get a gut feeling for when something's a crap source, like it's just someone's personal blog or it's some like real dodge looking newspaper or something. And then if it's say CNN, you're like, obviously they have their own bias, but
Yeah.
it's CNN, right? It's probably going to be checked. So in that way, I still prefer to Google because I feel like I can look at the source, I can get the context. If ChatGPT wants to give me something, I want to know where it got that information from.
I think it's very tricky. I think combined with the confidence where you always get like, certainly, here's your answer. And then you notice, ooh, right. I mean, but it's literally often wrong, more often than I was actually thinking. And when it comes to coding, it's simple because when you're a senior coder, you can tell where it, went off the rails and whatever. But I think especially when people use it for medical checkups and everything like that, it's
Please do not use it for medical checkups. Please do not do this.
yeah. But I think that's I have the feeling that's a general trend where it's going down. I mean, where it's going to.
Yeah, and like my niece is a Zoomer and she preferentially uses ChatGPT to check things. Like she's clever. I think she uses her common sense, right? But
Double check. Are you on TikTok, Instagram, any of these new millennial Gen Z
I
apps?
I am on Instagram. I've been a long time user. Yes.
Right. Yeah. Let's see. Let's see what the what the generation after us is gonna do. What I've been wondering about, and to be honest, so I'm hearing mixed signals. So I know that vibe coding was all the rage like 2 months ago. Now, almost when talking to people, I'm getting the feeling of, yeah, we're past that stage, kind of. And having talked about all these issues with hallucinations and confidence and assessments and whatever, do you really think you can vibe code yourself to become a startup billionaire?
Okay. So context on vibe coding as a term. So Andre Karpathy, absolute legend in the LLM space, he talked about this term in what, like January or something? 2 months later, there were 2 books released by major publishers about how to do vibe coding. Like it was like the pipeline from this term being invented to mean this is a cool way to prototype projects to this is literally how you can become a developer without knowing how to code was 86 days, I believe. So this is, I think, the poster child of what's happening in this space. Look, it's a little hard for me to say because I'm not a developer. I want to put the caveat in. I know there's things like security and maintainability and latency that are concerns that developers need to worry about. Me, as a data scientist in my pure, beautiful research world, I don't care about such things. But it comes back to the fact that I have not convincingly seen an agent being able to come up with an app that you, as someone who does not need to know how to code in that language, can ensure is secure, can ensure is performant. Now, for prototyping, question marks. I don't think you can become a billionaire off the back of that first application. You're going to have to get a developer in at some point. Maybe for just a proof of concept that works with like small amounts of data or like works as a cute form on a website or whatever. Sure, maybe. But as a developer, maybe you have better
I mean,
opinions about
I do
this.
share the same sentiment. I think there's the Twitter bubble, which is insane, by the way, or the X bubble or whatever, where people just vibe code left and right, and you see whatever they're selling or not selling or just faking. And I think that prototyping, yes, I think if you know what you're doing and if you're kind of senior-ish, it is superb, kind of, because you figure out when it goes off the rails and you can put it back. But as something for someone who doesn't know how to code at all and doesn't I find it a super tough sell. I mean, we're basically not there yet, I think.
I actually think a good example of this is, so as a data scientist, I don't really know any programming languages confidently outside of Python, R, SQL. SQL's a language. I'm going to defend that. But
You're right. You're right. Yeah, yeah, yeah.
I love SQL. I'm a SQL girl. So we were putting together some demos for a video. It was basically for our code assistant, Junie. And you helped me with this, with the Java ones. And yeah, Nicholas, another of our coworkers, he helped me with some prompts for TypeScript. So he's like, caveat, I haven't tested these, see how you go. And I tried one of the suggestions, which was to create a Pokedex application, keeping track of all your Pokemon, right? It didn't work after multiple tries. And when I tried to debug it, even with the refactoring capabilities within WebStorm, I just didn't understand why it was breaking. There was just too much code I didn't understand because I don't know TypeScript. And like for me, this was like it wasn't a surprise. Like I knew there was going to be a point at which the agent failed because it was beyond the complexity of what it could handle. But
it is exactly that spot where you get something up and running quickly, and then you might have to just change one line or a couple of lines, but you don't know what these lines are actually.
Yeah,
You
yeah.
don't know where the problem lies, and then I found 1, 2, 3, 4, 5 hours fixing this, or going in endless loops to the LLM saying, please fix it for me, fix it for me, fix it for me. It doesn't fix it for you. And then you just do it 10 times and you feel like literally you feel stupid because you're just, please really fix it. And the LLM goes back to you, says, by the way, now I really fixed it for you.
Thank you. That was a great question.
And so I've been stuck in those kind of loops.
Yeah. And like a counter example where I knew what I was doing, when I was first playing with Junie, I got it to create, I downloaded a classification data set and I said, create me a deep learning model to classify this. And I told it what the labels are and blah, blah, blah. And it actually did a pretty credible job because that workflow is pretty standardized. But I could see instantly problems and I knew what to fix. It was a completely different feeling from me in this middle of all this TypeScript going, oh my God, okay, this one didn't work.
Just for people to understand, and also for developers, actually, I think agentic can mean so many things, kind of. What is your definition of, if any, of what an agent really is? Because when I talk with different people, they all give me different answers.
So basically, what an agent is kind of what I described with, say, ChatGPT and Anthropic, right? But they can be much, much more basic. These are obviously super, super sophisticated. So with an agent, what you do is you take an LLM and you give it access to tools. And those tools can be anything. The very first one, actually, I remember was when ChatGPT introduced function calling. Do you remember that? It was like a while ago. But it was generally the idea that you could write Python functions to do API calls and things like that. The tools have obviously gotten a bit more sophisticated since then.
But now kind of standardized with MCP stuff.
Exactly. And MCP, just to kind of tell people in the audience who don't know, it's basically a protocol to standardize communication between LLMs and like tool servers. So say you've got an API that gives you weather updates. That's obviously going to have a specific way that it wants to receive messages. The LLM may send messages in a different way. Then you have this basically M times N complexity of the number of ways you can connect tools and models.
And by the way, shameless plug, I made a video about that on my channel, Marco Codes. Go watch it.
Marco does excellent videos, by the way. They are very entertaining.
Thank you.
Yes. So yeah, basically, as you've said, MCP, a way of basically standardizing this messaging and the connection system. So this sort of evolved, like the need for MCP evolved because it's obvious how beneficial it is to use tools with LLMs. So LLMs, like I said, they can do basic reasoning. If you put into an LLM something like, hey, I want a picture. Hey,
Hey.
this is me and
Yeah, yeah.
ChatGPT hanging out.
Hey.
Hey girl, how you doing? I need a picture of a cat. So if you tell ChatGPT, hey, you got access to DALL-E, an image generation model, or you've got access to an image search, it'll be like, okay, I'm going to decide which of those tools I think is most appropriate based on the description of the tools you've given me. And I'm then going to go and use it. I'm going to connect in some way, maybe through MCP, maybe through something else. And then I'm going to get the result and I'm going to serve it to you.
How would I just, again, for someone to understand, if I gave it 3 relatively similar descriptions of tools, how could I be confident in its decision of what tool it chose, kind of?
Yeah. So this, if you just give it the tools and the descriptions, you can't necessarily. Like, it's a bit more freeform. But there are frameworks where you can be a bit more directive. Like, you can be like, hey, or from the start, you would probably design your application so that you would choose tools for specific reasons. So you don't just give it access to a smorgasbord of tools. You give it access to the specific tools you choose. But yes, there are also ways through frameworks like Llama Index or LangGraph, which give you a lot more control over like how the LLM selects tools under which circumstances it would for which sort of context. Whereas something like, say, small agents, which is the Hugging Face way of accessing tooling, it's a lot more free. So the LLM will basically be like, all right, I'll make up my own mind based on what you give me. So yeah.
And then agents, essentially, also when you said it's an umbrella, I know we're building stuff with agents, sub-agents, handling then specific subtasks. Also, again, branching out, so a task is split up maybe in even different tasks and not just different tools, but I mean.
So these are called multi-agent applications. So the reason you might want this is for any reason that you might want to break a program down, like as it increases in complexity. So it might be there's multiple sub-processes. But an additional reason you want to do this with LLMs is because the way that they're doing all of these tasks is they have these chat templates. That's how they do all of these like interactions. But the chat templates are really just getting appended to each other and passed in each time you generate a new token. So if you're trying to do the whole thing, it can get very expensive, but it can also start, depending on the model and how big its context window is, it can start failing because you've overflowed the context window, or it can actually get a little bit confused because it's like, well, there's a lot of information in here and I can't parse it correctly anymore.
I don't know what that leaves me with now.
AGI.
AGI. But we're not quite there yet at AGI. But so I'm just trying to figure out how to put it all, because at the end of the day, still, what it looks like to me is I will still I'll probably have some sort of, so you just told me everyone has issues assessing the output, essentially. I mean, apart from the marketing material, which gives you different responses. Which leads me to think, I will just prompt my couple of favorite LLMs to give me some answers, and I just choose the one which I think is the best, and then I live happily ever after.
Okay, so there are a few rules of thumb. Basically, models need to be over a certain number of billion parameters generally to handle certain tasks.
Right, which I guess the state of the reasoning will all are. I mean, essentially the big one. Okay.
Yeah, and also if you want to do more complex tasks, so say you're building a multi-agent application, you may want a reasoning agent as the main controller of everything because they can parse more complicated instructions. We also haven't talked about self-hosting versus...
It's actually a topic I wanted to get into just right now, yeah.
Yeah, I think this is a consideration when choosing models because, okay, I talked about the fact these models are incredibly expensive to run. And that's because, let's say you're talking about a model of like a few 100 billion parameters. That model object might be like 40 gigabytes. It might be more. You then need to upload that to a GPU server. So it needs to be held in GPU memory. And basically, then you need to run inference through it. And remember, we're talking about autoregressive models. So what that means is that you pass in your initial prompt, it generates a token, it appends that token to the end, then it passes it through again. So it's doing many, many runs, sometimes hundreds of runs, depending on how long your output is per time that you prompt it. So yeah, this is expensive. And to do that in real time requires really beefy machines, and they're expensive.
The thing is, how would I even, as a company, how would I go about it? I mean, not just in terms of, okay, I need a hardware setup, which is
Mhm.
probably going to be expensive. Then I need some machine learning engineers. I mean, would I just take some random open source model, shove some data into it? Which type of data? How would I even train it? How would I go about training it?
Mm.
How would I then maintain it? I mean, could I just train it once, or do I have to train it like every 4 weeks or every week? How would I do all of that? I mean, how feasible is it as any sort of company, except the really big ones, to actually do that on a consistent basis?
So at the moment, no one is really training their own models, and there's kind of no need for it. So a while ago, the term foundational models was termed. I'm not sure how much I like this term, but the idea is that there are huge LLMs, many of them open source, and the open source ones, you can just use them how you like. So it might be that the LLM out of the box is good for you. We should talk about tuning. Actually, let's talk about tuning here. So also kind of to give a bit of context about what an LLM is, because you see all these like instruct, coder, like all these subtypes, and you're like, what's going on here? Basically, we talked about how the GPT models were trained, next word prediction. And a raw GPT model, that's what it'll do. It'll just keep
Giving
predicting
words.
tokens.
Mhm.
Yeah. Until it runs out of like max token. But in order to make them useful, you need to do something called fine tuning. So I think I talked a bit about what fine tuning is. You basically knock the bottom layers off the model and you train it to do something else. So you can do a few different types of training. You can do instruction training, or instruction tuning, sorry, where it's basically you design these data sets that are, here's a prompt and here's an ideal output. So basically, if I ask you a question, I want you to answer it. And here's a lot of examples of that. And you retrain the model to do that. You also, and you can do this at the same time, you can tune models so that they're basically chat models. So you train them so that they understand chat templates. And that's really important because then it sort of understands roles, and it also understands like end tokens. So it
Right.
stops.
Right. That was, by the way, when I played with, I don't know, I worked myself through an LLM book like a year ago,
Mm,
and then it told, it went through the history of the models, and that then with the end tokens, it just goes endlessly if you don't make it stop. And
yeah.
I was confused because I got into it also with ChatGPT, didn't know anything about it beforehand. And then you just get question, answer with different roles. But then when you see what these models do, and that they just, endlessly going to spew out text essentially,
Yeah.
it's interesting to see. Yeah.
You can actually still, on Hugging Face, they have endpoints where you can play with demos, like they're built into spaces.
Would you mind explaining what Hugging Face is to someone
Yes,
who,
yes, yes.
who
So Hugging Face is a French company. They have two branches. They have a for-profit branch and they have an open source branch. And their open source branch has basically become the place to access these open source foundational models, open source data sets. And they also have a lot of tooling that they have created themselves around how to work with LLMs in Python. Plug for Python. You should come over and join us. But basically, the company just like does a lot of work with LLM education as well. So I have sung the praises to many people before of their LLM course. I've actually just recently done their agents course. Also amazing. They're both free. You should
try them out?
you should
Yeah.
try them out.
Yeah.
But yes, back to Hugging Face. So Hugging Face, because GPT-1 and 2 are open source models. Well, GPT-2 is not actually open source. Sorry, I tell a lie, but it is at least freely available to use. Basically, like they've set up these endpoints where you can play with them, and you can actually see how these models were firstly before they got parametric knowledge. Some of the outputs are hysterical. I always ask them about Belgium. It always gives me like really funny answers.
Do you have an example?
Belgium is a small village. No, Belgium is an empty place that's not much more than a small village, like something like that. So like it grammatically makes sense, but it's just word salad. Like it's like someone, got hit in the head and yeah. But yeah, you can play with them, and you can also just see how it will just keep generating if you use it through the transformers package. It will just keep going. So we're talking about fine tuning. Yep. So instruction tuning, chat tuning, and by the way, instruction tuning can increase hallucination rates because it makes the model very eager to answer the question. Yes, because that's what we're being trained to do. Then we were talking about, why did we get onto this topic?
It's just the practicality of like a company trying to say, hey, kind of, I want to host my own model for whatever reason. Might be privacy. Yeah.
Cool. So you will have all sorts of versions of raw GPT models, but you'll also have instruction tuned and chat tuned models. But it could be that as a company, what you want to do is to train the LLM to actually learn more about your problem domain. So maybe you will have an inbuilt data set where you will, teach it more about the specific conventions of how your customers work, something like that. So in that case, you might fine tune, but you're not going to train a model from scratch anymore. It's a waste of time. It's a waste of money. But fine tuning, it's a lot of work, but that would probably be as far as you go as a company.
But that means, as you said, I need some sort of a foundational model and someone who understands the fine-tuning process. And then it's not just about fine-tuning process, I guess, but getting the data in the first place.
Yes. Yep.
Then we are back to the assessment problem where I say, well, how do we actually know that, the stuff kind of worked?
Yep. And now you're talking about a proper data science project. This is not quick or easy. But let's say you don't need to fine-tune. Let's say you are happy to just use the chatbot model, instruction tune model out of the box. Well, in that case, you still need an MLOps person who can host this. And you're talking about all of the regular problems that come with hosting some sort of large and complex app. And in addition, you are going to need to be able to assess if it works for your problem domain as well. This will be the same problem, though, you have if you decide to use one of the proprietary models,
right,
where they take care of all the hosting. Because here's the thing. Assessment of LLMs in the context of your application is exactly the same, pretty much, as assessing if an application works. You still need your unit tests. You still need to inspect things like traces. You still need to get humans in the loop to check things out. You still need to do A/B testing. And so it's a really nice blog post. I will send it to you so you can share it as part of the episode notes. But it basically, AI engineer talks about this whole process of how his team did this for a real estate, it's like a real estate chatbot to retrieve customer information and answer other questions. And they were like, hey, we were just doing like vibe assessment at the beginning. And then we're like, this is not working. Like as all the edge cases came up, they couldn't work out if it was working anymore. So it's just like, again, machine learning fundamentals, if you're talking about stuff specific to models, but the model in the context of an application is just classic software engineering. Like you need to just a few tweaks, but you just need to understand, like, is this working for my customers? Not magic.
I was just wondering if I try to fine-tune a model or try to offer some random powerful online model all the data I have through MCP, for example, and then just hoping for the best. Would there be kind of a difference, kind of?
So the model to train itself or give it access to it? Like
just give it access to it? Or maybe.
Like in terms of the quality? Okay, a few complications here.
Yeah, sure.
Yeah. So the first is that, again, we're probably talking about like a RAG pipeline, right? So unless all of your stuff is built into a good search engine where retrieval is taken care of. So like before, I'm sure a lot of you have worked with search before, but before we had semantic search, you just had search, right? Where you'd index terms from text and things like that. Search is not magic. semantic search is not magic. It's not fallible. So being able to like set up, like tuning RAG pipelines are really tricky. Like being able to actually retrieve the correct information, like, do you have like maybe a long chunk where, because you could break the text down into chunks, do you like break it down into small chunks, or do you break it into big chunks? How long should the prompt be to actually give enough information? So yeah, it could be better if it had access to a lot of information, but it needs to be like searchable in a way that's meaningful. Again, not a like magic problem. We come back to search. And again, the model still needs to be able to use that information. So it needs to have like a good-ish rate of faithfulness hallucinations. So yeah, I'm sorry. I got no magic bullet for you.
No magic bullets. It kind of leads us, however, a bit to the topic of, let's say, privacy concerns that people might have of sharing their company data with LLMs.
Yeah.
What's your take on that, by the way? Do you think that, are you essentially scared when typing anything into the one of the modern models that they will take you? Do you have that in the back of your mind?
I'm always careful about what I type into them. And we should also talk about the different sort of contracts you can have with models, right? So we work at JetBrains. We have worked out an agreement with our providers, which doesn't allow them to use the data for training. But if I'm just using ChatGPT through my personal account, we have no such agreement. That's part of the $20 a month I'm paying them. And I suspect part of the reason for this, look, I don't work at these companies, I don't know. But basically, the amount of data of sufficient quality to train these models on, we may actually be running out of it. And like you said, a lot of part of the problem is this slop that's coming through that's just flooding the public internet. So potentially that data that you're inputting into an LLM probably becomes more and more valuable to these companies because it's probably real and it's chat data as well, which is what they want for training. So just be very, very careful. Just be careful about what you put into these models. And I think
as a company, then, however, that almost sounds like you would like to try to go back to the hosting point earlier. You would actually try to host everything locally as much as you can.
Yeah. I remember having these conversations. So our AI assistant was in beta from like March 2023, I think. Something like that. Like it was early mid 2023. So I remember I was at EuroPython and I was doing AI assistant demos. And big companies, like people from big companies, the question they would always ask is it going to be safe for me to put my data into this model? And I was like, at that stage, I was like, I think so, but I'm not entirely sure, like, because I wasn't entirely clear on the legal agreements we had. And they're like, yeah, even if you say you have these agreements, I would still feel much more comfortable self-hosting.
Understandably, yeah.
And for a lot of them, yes, like this is also, it's just how they've always been with data. Like we have another product, data law. And one of the biggest like customers we have is people who want to host it on-prem because they don't want their data to leave their ecosystem. So if you do not want that, your only solution is self-hosting.
Especially in the context, which I find interesting, of, let's call them ethical concerns, because when we think about how these models were trained in the first place, and then all the lawsuits that came after it, where, for example, Reddit went versus Anthropic, and just where, hey, you just took all our data, and the OpenAI copyright suit, lawsuits, and whatever,
Yep.
and the book authors, everyone basically saying, hey, you're ripping us off.
Yep.
How ethical has all of that been? I mean, to get where we are today.
And there have been a lot of ethical concerns. So apart from the sourcing of the data, by the way, the latest lawsuit is Midjourney is going to be sued by Disney and Universal together. That is not good. But I think it's interesting because we went very, very quickly from open source research utopia. this is where we were. Everyone was like, hey, we're doing this for the benefit of like machine learning research. We are trying to do something new and exciting here. And actually, let me talk about where kind of the foundational data set came from for NLP. It's called Common Crawl. So Common Crawl was a project that came in, let's say 2007, 2012. I can't remember the exact year. It's quite an old project at this point. But generally the idea was they saw how Google's crawler kind of went over the public internet, and they wanted a comparable open data set to train new search engines or do natural language processing research. So information retrieval, NLP. So Common Crawl is like the most frequently linked pages on the open internet. And obviously, quite a lot of those are going to be copyrighted material. But it was all just for research, so it didn't matter at that point, right? I imagine under the copyright usage, this was fair use. The problem is, while there have been additional data sets that have been pulled in, they're all still from the public internet. The cleaning processes that apply to them, because there is cleaning done to them, cannot be done manually because the data sets are too big. And so you can't guarantee that certain things will be excluded. That's both for quality and for ethical use. And now all of a sudden we switched very quickly to this now becoming a $1 trillion industry, although how much of that is going to pay out in
a
actual
$1 trillion loss industry, maybe.
$1 trillion loss industry potentially. There are still some use cases for these models. I don't want to write it off, but yeah, like I really don't want to write it off. There are still some really interesting things in natural language processing that we can do with these models. But all this stuff about like them doing advanced reasoning tasks and stuff, it's just not going to work. Actually, I think I read that something like 75% of AI apps fail not because of interest, because they just can't be assessed properly. They just don't work. Anyway, going back to ethical use of data, that's not the only problem. The early kind of transition from GPT-3 to ChatGPT involved the use of additional models. Basically, they had this process, like a training process, where they were trying to get data to build an additional reinforcement learning model. So they would get this fine-tuned GPT model. They'd get it to output 4 different outputs for the same prompt, and then they would get people to rate them from 1 to 7. Yeah, I'm sure you remember this. Mm-hmm. So it was later discovered this was done through an outsourcing firm. These people were in developing countries. They were being paid very little. And they were exposed to, because this was the unfiltered model without guardrails, traumatic material. So there's been a lot of really serious ethical questions about the data sourcing for these models. And this is also a fundamental truth of machine learning. There are no shortcuts to good quality data. And it's either bad and plentiful, it's cheap and expensive, or somewhere along the line, you've taken a shortcut and you've gotten someone to do it for cheap. So, yeah.
And do you see any of the companies, taking responsibility? Not of the companies maybe, but anyone sort of...
I don't want to say that no one has, because it's not necessarily like I'm out looking for it. Sure. I haven't seen it, but that's not to say people aren't and I've just missed it. But I think the general consensus is there's been much more discussion about it in the last 2 years. So there's prominent AI ethicists like Timnit Gebru, Margaret Mitchell. They are speaking out about these issues, and they really sort of brought this stuff to the fore in like 2023. But it's still an unfortunate truth that you can't have these models without the data. It's, I would say, a bit of an analogy for how the world works, right? Like I can't have this cheap clothing without it being off the backs of someone else. So I'm not saying it's right, but I am also saying that I think like many issues we have in society, it's something we don't want to examine more closely.
Mm-hmm. How about examining environmental concerns? Yes.
Do
you think, I know a couple of colleagues who were very strong on hey, we're blasting through so many resources just to train them, is it from your understanding, is it environmentally, concerning what we're doing?
Yeah. So the new data centers that are being built in the US, serious question marks about the sustainability of it. We've already heard problems with like places with huge data centers running low on water and things like that. The amount of electricity needed to power some of these things is as much as a small town. What I would say the silver lining is that, like I said, DeepSeek rocked everything to its core. And I think what it's kind of forced the conversation to turn to is, well, we can have smaller models and performance. And that's where we need to go. And that is actually where things have been going. Kind of part of the problem, though, is there's a lot of sunk cost into these huge models that were trained earlier and they're still being used. I don't know exactly what the state of the industry around this is right now. I would just say my gut feeling and my hope is that competition, economic competition, will just force smaller models, because who wants to pay $17 for 1,000 tokens when you can pay 0.000017 of a cent or 1/7 of a cent?
By the way, the whole price and the cost of it, when I'm using one of the new coding agents and you just see your credits go,
Oh, yeah,
and
yeah.
it's a simple task, and then it's suddenly out of credits. Interesting.
Yeah, because of the amount of steps
Yeah.
and the fact that everything just gets added to the context
Yeah.
window depending on how the agent is built. So yeah, it's just the more steps it does, they all just get appended. And yeah.
Which brings us to, I'm not going to say hot takes, but we're almost at the AGI stage. We're going to hold off on it. Just one more question. Do you think that, just in pure terms of development, do you think that the market is really going to stop hiring juniors because now all the tasks can be done through LLMs and agents and whatnot, and then we're going to run into a problem with and having no seniors in 5 years or in 10 years time? What's your take? What's your take on that?
Companies are already doing it. I think there was a well-publicized case here in Klarna, here in Germany about Klarna. Did you see that?
Nope.
So I can't remember the particulars, but I think Klarna actually fired a bunch of people and then had to rehire
Rehire them.
them.
Yes,
Yeah.
I did. Mm-hmm.
But I don't remember if they were junior developers or not. I would sort of say that I can't attest to what a company is going to do. But in the end, the development team is just going to keep getting more senior. If you don't promote them, they're going to leave because you're like, well, you should stay as a mid because we have no one under you. Sure, it's hard economic times, so maybe it's not so easy right now, but the market will recover. I'm sure of it. And in that case, people will have the ability to leave again. Again, the only thing, and I hate saying this as someone who comes from a research background and used to be very idealistic about the world, but the only thing that really makes change is economics. And the only penalty that will matter is economic. And so basically all your developers leave because they have no freaking juniors to take over. This is probably going to be the incentive, because the thing is, the consequences will not be felt by management. And while we're still in a market where they can undercut mids and hire them at junior wages. Now, as to whether these tools actually increase productivity that much, I do actually think they increase productivity quite a lot. Do you still need to be a skilled developer to use these tools correctly? Absolutely. If you are a junior developer, my friend Laila Bugliari did an excellent keynote at NDC Oslo last month. She talks a lot about this issue. Please do not neglect developing fundamental skills the hard way. You need to fail, you need to learn. Don't get lazy and let LLMs outsource your critical thinking. And I find myself doing it also. It's tempting, but you need to struggle a bit to learn this
It is
stuff.
super tempting. And to be honest, I mean, now you get stuck. I mean, back in the day when you had even so, I think because I had an older brother who had, for whatever reason, a 56K modem back in the day, but there was nothing online, nothing out there online. So when
Yeah.
you wanted to do some programming, you had to rent a book from the library or buy a book, and that was it. And you couldn't ask like 20,000 people on Stack Overflow or what the problem was. And now that has changed so much. You can just you just get stuck and
Yeah. And I can even say, like, I'm newer to programming. So I probably learned to code about 12 years ago in Python. I fell in love immediately because it was Python.
yeah.
But it even then, even with all the ability to Google and stuff, it's so important to be like, hey, like even the step of I need to know how to Google an error message instead of, well, letting AI explain error messages to you, I think can be useful as long as, again, you have a bit of a gut feeling as to whether it's telling you rubbish or not. It's really important that you also learn your fundamentals and learn them in a structured way. So like do courses, like if you didn't go to uni for computer science, like take the time to at least learn things in a structured way, because otherwise you have no foundation to really rely
And
on.
I think maybe people need to hear it. You need to struggle. So
Yeah.
it needs to feel painful, kind of.
And not entirely for like it needs to feel a little frustrating,
Yeah,
and you need the intellectual
yep. satisfaction
satisfaction of that payoff. You need to push yourself. I'm not saying you need to suffer to be a developer.
Yeah.
Like it's a great career. It's really nice. But yeah, you need to be sitting there with that. Okay, actually, I'll tell you a story about like it's amazing I'm still here. So I learned basic Python, then I put it down for a while because I had no use for it. And last days of my PhD, I picked up R.
Mhm.
And I was like, I'm going to learn R to do my last of my stats. And I was learning from this textbook. And the first exercise was to read in the data file, right? It took me 2 hours. I kept getting an error. I did not understand this error. I had a Windows machine and I was learning from a book that was based on Unix. The slashes were the wrong way. I was crying. I was like, I'm so dumb. I can't do this. But I persisted. And now I, know how to code, I guess.
Yeah, but people need to hear the story because especially these types of problems with the wrong slashes or different format, you run into them over and over again, and you blast through hours and hours and hours of yeah.
And here's the thing. I would have instinctively understood what was wrong later, but at that point I had no framework because I'd just done some basic Python and then put it down for a year. If you don't encounter these problems and solve them by examining the error message, understanding the context of the code, if you're always getting the LLM to generate the code or solve the problem.
Yep. Including hallucinations. So I was coding something a couple of weeks ago, and I was trying to be sneaky and asked ChatGPT, hey, does MySQL, the database, have that functionality? And it said, yes, sure it does, since version 7 point something, kind of. Tried it out, didn't work. Then I read the official documentation and said, nah, never worked. The feature doesn't exist. So, I mean, it was just very confident in telling me the feature existed. It unfortunately never existed. Blasted through 1 or 2 hours figuring that out.
But if you didn't know to go to documentation, you never would have solved that.
Yep.
Yeah. And it's also like, here's something that I think needs to be said. Again, these models work well when they have a lot of training data. If you're dealing with newer frameworks, if you are dealing with languages that are newer like Rust, they are not as good. They cannot be as good. So you need to be careful.
Yep. Which brings us finally to AGI.
Oh, yeah.
Just briefly, by the way, because I also have the feeling that a ton of people understand different things on the AGI for whatever reason. What is artificial general intelligence to you? What does it mean?
Okay.
And where are we? And are we going to be there in 5 years as people online are going to tell us?
No. No. This is the one 5-year prediction I feel confident making. That's the others no, but this one I'm going to bet 20 euros. 20 euros with one person. I'm not going to give out huge amounts of 20 euros. Not that rich. If we have AGI in 5 years, I'm going to give you 20 euros.
Cool.
All right.
Okay.
Yeah, because I won't have a job, I guess.
Right.
So
Yeah. Then right.
you'll need it because you won't have a job either. Yeah. I'll save it.
We can meet back here and do podcasts on random topics.
Yeah, that's right.
Yeah, right.
Um,
yeah.
So let's go back to AGI. So AGI is a very, very poorly defined term. I can't really tell you what I think it is, but I can tell you what Francois Chollet thinks it is. So Francois Chollet is a very well-known computer science researcher, expert in AI. He was at Google for a long time as, I think, the head of their AI department. So he wrote this beautiful, very dense, but very nice paper in 2019, actually, called On the Measure of Intelligence. And basically what he points out is, hey, we have like all these people running around talking about how we're going to achieve general intelligence in artificial systems. But basically, none of them really have a background in psychology. So maybe we should think about psychology. Obviously, having trained in psychology, I always want to put this caveat, it's a problematic field, real problematic in many ways, but there's at least a framework for thinking about what we're trying to get to. And kind of the core idea of intelligence in humans is this thing called G, general intelligence. And then what happens from general intelligence is it forms what's called crystallized intelligence. So you have this general ability to learn, to reason, to synthesize facts, things like that. This is what G allows you to do. And then you crystallize that into being able to do specific tasks like take exams or drive cars or cook or do a podcast. So what we're trying to get at, and this is what Chollet puts out in his paper, is we need some way of assessing the true generalizability of problem-solving capabilities of models. Now, this assessment in and of itself is a very non-trivial task because if you think about the core of what you're trying to do, you're trying to create one standardized measure that will assess for all models how different a task is from things it's seen before, what Chollet calls the generalization difficulty. You don't know what these models have seen before. Like this is a fundamental problem because we don't know what they were trained on. And also being able to do that because like if you're going to make it a human-like intelligence, because let's narrow it down, it needs to be representative of all of the scope of tasks you'd expect humans to be able to do. And so how can you do this? Like you can, but it's very, very difficult. So Chollet has like a measure, which is called the abstraction and reasoning corpus, I think. It's ARC for short. They're working on the second version at the moment. It's a private test data set that reminds me actually of this intelligence test called Raven's progressive matrices. But what it is you show a model these sort of 3 examples of patterns, like sort of problems, and you say like what should be the next one in the sequence, and you basically have to work out what the rule is in the pattern. So he's sort of like, this does force a degree of generalizability. This is sort of his argument. I'm not entirely convinced by it, but like I like the effort. Like I think it's really cool that he's thinking about this and he's not just relying on text-based problems. Like it's a real kind of attempt to kind of force models to have these kind of multiple states of symbolic reasoning. But yeah, no one's really close to even defining it. And like it gets really stupid when we start talking about things like ASI. I hate the term ASI, artificial superintelligence, because now what we're talking about is an intelligence that's beyond human. Okay, so what does it do? Like, what are tasks that are not capable of being done by humans that are relevant to humans? Or are they maybe not relevant? Like, what are these tasks that this thing can do?
Are there any examples of such tasks? I mean,
like the best task the best example I can think of is not even like something that's like, okay, so Chollet gives an example of something that's like beyond human-like intelligence. And it's like the behavior of an octopus when it needs to camouflage. It's very intelligent behavior.
right.
It's not something humans can do. And it's not really relevant to us and the tasks we do. So people are not even clear. Like they're like, does the task need to be relevant to us, but it's just beyond our capabilities? But what are our capabilities? Like what's the limit? Anyway, this whole thing is a very stupid debate. Anytime someone says, it's around the corner, AGI is around the corner, I'm like, tell me how. How do you know? How do you know? It makes me angry.
I love it. I love it. Which brings us to something which might not make you angry anymore.
Good.
Which is, I have a couple of questions prepared for you. I mean, on top of what I already asked you, right? Yeah. A couple of rapid fire questions.
Okay.
Maybe it's a bit of background in case anyone couldn't have told. You're from Australia originally.
Yes.
You live in Berlin.
Yes.
We are in Berlin. I'm German, right? And I thought.
Now I'm nervous.
No. I'm going to ask you a couple of questions which have a reference to our nationalities and LLMs.
Oh.
And let's see what's going to happen.
Okay.
Which is harder for an LLM to decode? Which is harder for an LLM, decoding Aussie slang or handling German compound nouns? Right. And by the way, remember we practiced beforehand Autobahngeschwindigkeitsbegrenzung. Yeah, that's what. Yeah. So I don't know any Aussie slang terms, but maybe you have.
Okay, so a drongo is like an idiot. A dag is someone who's like kind of nice, but like not very fashionable. Like dads are dags, and something can be daggy as well.
All right.
Yeah. Let me think of some more.
Okay. But which one's more difficult, do you think, for an LLM?
I'm going to say, based on the amount of training data, I think it's going to be better at German compound nouns.
If a model says, no worries, mate, in response to a GDPR violation, would you laugh or panic?
Panic.
Panic?
Yeah. I do live here in... I would be responsible for the GDPR violation. So that's... I've dealt with German bureaucracy.
Yeah, right.
Yeah.
It's great fun.
It's a little scary.
If you wanted to spark great AI product ideas, would you go to a beer garden or to a beach barbecue?
Beer garden.
Beer garden. Are you a fan of beach barbecues though? I mean...
No, but let me tell you a fun fact about Australia. We have coin-operated barbecues in our parks. So you go down, you go to a park and you just there's just these big kind of solid barbecues and everyone somehow cleans them in an honor system, which is amazing because we're not a very communal society. And you just put like $1 into the barbecue and it just works until it times out and you put another $1 in.
Really? So you like $1 for whatever, 30 minutes of barbecue? And it's just...
Yeah.
Amazing. Didn't know that.
Yeah.
If GPT had a favorite national dish, would it be schnitzel or would it be meat pie?
I think it would be Käsespätzle.
That's actually my next question. If you would name a model after food, would it be Käsespätzle 2 or would it be Lamington GPT?
Lamington GPT.
You have to, because I didn't know what Lamington was, you have to explain to people what Lamington is.
Okay, so a Lamington, you basically take white cake, what Americans call white cake. It's just like a sponge cake.
Like lemon cake? I mean,
not a sponge cake. Like it's just a normal vanilla cake. And then you cut it, you bake it in a sheet and you cut it into like rectangles and you dip it in like it's like a chocolate sauce, but it's not made from chocolate. It's made from cocoa and water or cocoa and milk. And then you dip it immediately in coconut. And then the best ones is you cut it in half and you put jam and cream. They're quite messy to eat, but they're delicious. Yeah, but I think Käsespätzle too, as much as I love Käsespätzle, it's got 2 umlauts in it, and it was very difficult for me to learn to say that word.
But you say it perfectly.
Because I eat it all the time. It's my favorite dish to order at German restaurants.
It is really good. You just have them by themselves? I mean, just Käsespätzle or Käsespätzle with something?
It always comes with the salad with like the senf.
Yeah, but no meat or anything like that. No,
I'm vegetarian, remember?
Oh, I forget.
Yeah.
I'm stupid.
Yeah, right. But also like...
So by the way, asking you for schnitzel or meat pie is such a fun question. Okay.
No, but it's also because schnitzel is Austrian. Is it not?
True, it is. But there's also Munich schnitzel. I guess we Germanized it also. I mean, that there are German schnitzels and so
I just did my citizenship test. This is how enculturated I am.
What was the hardest question on the citizenship test?
I can't remember, but there was all these ones that were about like the particularities of like who votes for who to get like particular, like there's like the Bundesverfassung or something, like there's like some board that gets together, like this group that gets together to vote for who the president is.
Right.
And it's just
Right. I would
Bundesversammlung,
fail it.
Bundesversammlung,
Yeah,
something
but
like
maybe
that.
Bundesversammlung, maybe, yeah. But
Yeah,
maybe,
I don't
yeah.
know. But I do remember that Konrad Adenauer was the first chancellor of the Bundesrepublik Deutschland, which was founded in 1949.
Right, that's great. Do you know his nickname?
No?
I think he was called the Old One. I think. I'm not.
What the hell?
Maybe I'm just
That
misremembering.
just sounds like
So
Lovecraftian. Like, what the
I'm
hell?
just now hallucinating. I'm going to give you a confident answer. I
Old
think it was
one.
the Old One. Maybe I'm totally wrong. People can tell me in the comments. To finish off, your favorite model, if you had any, if you could choose any of these models out there, do you have a favorite one and why?
That's a good question. I think, okay, it's not a current model in use, but I have a real soft spot for GPT-3 because it was the first model I used where I was like, holy moly, like this was in the ancient days. But it's kind of my favorite. Yeah.
Thank you very much. I need to mention something, by the way. We do have a tiny giveaway, which means if you write in the comments down below this video, the craziest, funkiest model names you can think of. So you heard Käsespätzle 2, you heard Leamington GPT. Doesn't have to be about meat pies and schnitzel. So it can be vegetarian, vegan, can be anything you like. Let us know in the comments. We're going to raffle some coupons for our merch store, the JetBrains merch store, and licenses. And we'll get in touch with the most creative comments out there. Thank you very much, Jodie. I learned a lot. It was a pleasure. And I don't know, let's go eat some Käsespätzle.
Yeah. Oh no, we're in Berlin. Let's go eat some vegan currywurst.
Vegan currywurst it is.
Yeah.
Thank you.
All right.